All right. Welcome back from break, everyone. We're going to go ahead and launch into our next panel, which is about cooling tower efficiency. So if there's one thing that we learned from Carrie and the rest of our presenters is that we need to be prepared, and that we want to look everywhere we can for water savings and water conservation savings. And we want to do it before we get in an emergency. So we have two great presenters today talking about cooling towers. One is from the city of Austin, talking about a program they've implemented. The other is from the Alliance for Water Efficiency, talking about a whole suite of tools that they've developed to help utilities explore cooling tower savings and how to catalog cooling towers and all that. So I'm going to go ahead and introduce our two speakers, and we'll launch in the presentation and have Q&A afterwards. So Brad Spilka is a program associate at the Alliance for Water Efficiency. He is joining us from Chicago right now. He works on projects relating to water conservation, program planning, policy analysis, research, and technical assistance. And Daniel Cavazos will be joining us from LCRA and with the in-person group of folks. And he is with the city of Austin. He's an environmental compliance specialist at Austin Water, and he is working on helping to implement Austin's new cooling tower ordinances. So without further ado, I'll pass it over to Brad and then Daniel, and we'll have Q&A.
All right, thank you, Jennifer. So my name is Brad Spilka, and I will be presenting on the Alliance for Water Efficiency's Cooling Technology Study. Oh, there we go. All right, so first I want to start off with a little background on who we are. The Alliance for Water Efficiency is the only nonprofit in North America focused on the efficient and sustainable use of water. We serve as a North American advocate for water efficient products and programs and provide information on and assistance on water conservation efforts. Our membership network includes over 530 members in 200 watersheds, delivering water to over 50 million users. So we have a huge network of utilities, other stakeholders all across the country, and we like to consider ourselves just a hub of different research, resources, policy advocacy, and networking for those in the water efficiency and conservation space. But getting on to what we're talking about today, I thought I'd start by giving everyone a quick little background on a cooling tower. So what is a cooling tower exactly? A cooling tower is a heat rejection device that rejects waste heat to the atmosphere through the cooling of a water stream to a lower temperature. As pictured in the diagram in the top right of my screen, cooling towers recirculate water to remove heat from air conditioning equipment in buildings. This heat is then rejected from the building via evaporation and into the atmosphere. That was the what, so next is where a cooling tower uses. Cooling towers are found on top of office or next to office buildings, large multifamily buildings, schools, hospitals, resorts, data centers, airports, industrial and manufacturing facilities. They're way more common than you really would think, and once you actually start looking around for them, you're gonna notice that, hey, there's a lot more than I really ever thought. As pictured in this screen, you can see a lot of times they're on the roof of buildings and they're very inconspicuous, but once you kind of know what you're looking for, there's a lot of them. And getting back to the next slide, why is this project important? Well, kind of just giving a little background, but the average person doesn't really know about or understand cooling towers. And until now, there was really no way to even quantify how many cooling towers were in a water provider's surface area. So this has really made it difficult for water providers to include cooling towers in their water efficiency programs. But more importantly, cooling towers have immense water savings potential. According to industry experts, cooling towers on average account for 40% of a building's water demand, and in some buildings, they may account for far more than that. This makes increased efficiency in cooling towers a prime opportunity for water savings in the commercial, industrial, and institution markets. So here we have cooling towers. They're these massive water users, and we don't really know a lot about them, and they've never been incorporated in water efficiency programs. And with droughts the way they are nowadays, and the importance of efficiency and conservation at a peak in the world's history, it's important to take advantage of every opportunity as possible, just as Jennifer mentioned when opening up the presentation. So cooling towers have an immense opportunity, but really have not been discussed so far. So that's where we come in. So here's a little background on the project team. AW assembled a great team to further research cooling tower water savings potential. This was led by the Pacific Northwest National Laboratory. They were the brains behind most of the research here, while AWE, Mariner Besnick and Associates, and a large project advisory committee oversaw logistics, data, writing up reports, and completing deliverables. And just to show you how big of an impact all the utilities and cities had, here's a whole slide. We can't thank enough the various project advisory committee members and funders that made this project possible. As you can see, we had utilities and cities all across North America participate in this project in one way or another, and we really could not have done it without them. And it also goes to show the immense interest that people have in this project and this type of research. So it's a really important thing, and we were glad to have this many utilities and cities interested in helping create these resources. So our goal for this was 5 main objectives. 1, develop best practices for identifying water-cooled facilities in urban areas. As I mentioned, cooling towers are all over the place, but it's always been hard to quantify how many. And water utilities can't exactly create programs until they know how many water cooling towers there are in their service area. Number 2, develop best practices for estimating consumptive and non-consumptive water demands for cooling. This was a whole lot of research to see really how much water cooling towers use in both a consumptive and non-consumptive manner. Number 3, determine the conservation potential for improvements to traditional cooling technologies such as cooling towers. We looked at the different ways that cooling innovation can improve conservation potential on cooling towers. Number 4, determine the conservation potential of alternative cooling technologies. Cooling towers aren't the only technology that cools water and serves as a cooling mechanism for large CII buildings. There are other alternative cooling technologies out there, and we want to investigate the potential and validity of those and the water savings of those as well. And number 5, develop practical guides, incorporate study results to increase the effectiveness of cooling water use efficiency incentive and outreach programs. Here we just wanted to create a large host of deliverables so that water utilities, cities, and anyone else who is interested across North America could use this and have cooling technology studies to use for their own service area. So here we go through the project resource. Our project team worked to create a variety of resources and deliverables to further uncover the potential of cooling towers and water efficiency. In these next few slides, I will go over all 4 of these resources in depth and explain how they each uniquely contribute to water conservation and efficiency research in cooling towers. So the first resource I will discuss today is AW's cooling tower estimating model, which is the most important research in this entire project, in my opinion. So AW's cooling technology estimating model, also known as CTEM, is a first of its kind Excel-based model that takes characteristics of a service area and provides water suppliers with an estimate of the number of cooling tower units and the associated water use. The model also provides a mechanism to identify and record the location of facilities likely to have cooling towers. Notably, the model creates these estimates based on statistical correlations between building features and their likelihood of having cooling towers. The Excel tool was released in tandem with a guide that is a companion to CTEM, and the guide provides straightforward instruction on how to use the model, identify cooling towers, and initiate a cooling tower inventory. The guide is a step-by-step look at every single input and every single sheet in this model, and it makes it incredibly easier to use. So here I have a slide that shows just so everyone can see what data CTEM is based off of. So this is the very first thing you do in CTEM. If you look in the different orange boxes, you will select the country, your state, your county. You'll enter the population served, the water quality measurement type, and enter the water quality. And you enter all this data into the tool, and the model will generate an estimate number of facilities with cooling towers, a total number of cooling towers, total cooling capacity, consumptive and non-consumptive water use, and large-scale facilities that are likely to have house cooling towers, such as airports, data centers, universities, and thermoelectric plants. So this results tab is really crucial, and it also determines the water savings potential from adjusting the cycles of concentration. Further down the results estimate tab, you can see where users can adjust the duty factor, which is estimated from climate data that we use for these calculations. The inputs, results, and analysis go way beyond what is presented here. And I'm just giving everyone a basic summary to give everyone an overview of the cooling tower estimating model. Otherwise, I could talk way above my allotted time frame on this. It's a really incredible tool, and there's so much data you'll be able to sift through just by putting in just a few basic parameters as I've shown. The next resource I will go over in the project is the Water Quality Helper. This tool allows you to enter water quality parameters to identify factors that may be limiting the water efficiency of cooling towers in your area and direct you to potential solutions to improve water efficiency. It is a standalone file, but was also recently added to the CTEM model. So here, if you look at this slide, you enter the source water values, and the model estimates cycles of concentration and provides recommendations for a system without any water treatment. The biggest takeaway from the Water Quality Helper is that there are factors that aren't completely water-based that might be limiting efficiency, and this Water Quality Helper can look at those factors and see how you can maximize water efficiency by maybe changing certain source values. Oh, I'm sure by now a lot of you are wondering, how can I access CTEM and use this great resource? Well, CTEM is free for all AWE members. You can visit www.allianceforwaterefficiency.org/resources/topics/CTEM, or you can just go to the Alliance for Water Efficiency resource library and type in CTEM, and it should pop right up. On April 14th, 2021, we held a webinar, and it basically was a step-by-step comprehensive overview about how to use the cooling tower estimating model. And it's a great webinar, and it pairs well with a companion guide because, you know, here at AWE, we know that cooling towers are a very new technology, and everyone might not have the intuitive knowledge about cooling towers. So we tried to lay out as much information as we could and give step-by-step so that really anyone who knows about cooling towers in their service area can use this and understand this and accurately fill out the tool and get a great estimate for potential water savings. So as I mentioned, AWE not only looked at cooling towers, but as part of this project, the project team also investigated the conservation potential of alternative cooling technology. We investigated the water savings and energy impact potential of 8 select add-on and alternative technology. From there, we identified 3 technologies that were to be discussed at length The three of those were adiabatic cooling, salt-based ion exchange systems, and water recapture systems. These three were chosen because they were the most viable for water efficiency and conservation in the long term, compared to the main 8 that we started with, and these were the ones we recommended to go forward with and feel that they have the best potential. So the results indicated, after looking at these 3 alternative cooling technology in depth, that the 2 most promising technologies are salt-based ion exchange and adiabatic cooler. And while cooling tower water recapture showed promising water and energy reduction savings, the results were left inconclusive due to potential trade-offs in capital and recurring expenses until a life cycle cost analysis can be completed. So I know that was a lot right there, but alternative cooling technology, we are putting out a lot of resources on it. The first one is a big report, which is going to go way more in depth than what I just talked about on those 3 different alternative cooling technologies. It's a whole report that analyzes the validity of the water savings and efficiency from those 3 technologies. And it's going to be released very soon, probably in the next month or 2. Our team is working on finalizing that deliverable. We are also in the process of completing a market penetration model, which will assess the uptake of alternative cooling technologies. Here on this slide, you can kind of see a screenshot of this model. Once again, our project team's hard at work getting this finalized, and ComEd commissioned this report and market penetration model. They've been a huge funder, and they've really seen the value of alternative and regular cooling technology, and we'd like to just thank them again. So our next steps: AWE, PNNL, ComEd, and the entire project team are moving forward with the final deliverables, which are to be released by the spring of 2022. We have a final report that encompasses everything that I have talked about today and much, much more. The next deliverable is a how-to guide on setting up a cooling tower water efficiency program. So if you plug into CTEM and figure out that you do have a lot of cooling towers, the how-to guide will kind of give you some advice on how to guide and create a water efficiency program based on cooling towers. Our next deliverable is a summary of a cooling tower water efficiency strategies and how to select what is optimal for a given service area based on water quality and climate. Obviously, cooling towers work differently in Seattle, Washington than they do in Austin, Texas. So this document will just have different strategies to see how you can maximize the efficiency of cooling towers based on where you live. A cooling tower audit assessment form. So this is just basically a simple audit tool that will assess individual cooling towers that anyone can fill out. We're also creating email templates to connect with different people in the industry for outreach and follow-up. As I've mentioned many times, there's kind of been a knowledge gap in cooling technology for a long time. So there are some people out there that know a lot, but there's a lot of people who don't know much at all about cooling technology. And we're trying to connect as many people in this space as possible, because a lot of utilities across North America are dealing with this issue. And we want everyone to have as many resources as possible and be able to bounce successful ideas off one another in regards to water efficiency programs and cooling towers. And finally, we're creating a return on investment calculator to evaluate the efficiency improvements for individual towers. Obviously, cost benefits, having cooling tower water efficiency programs costs money, as do any water efficiency program. So we want people to be able to put in their financial information and show that this will be a profitable and also water efficient program. So that really wraps up everything I had to say today. As previously mentioned, many of these informative cooling tower project deliverables are still to be released. They will probably be released in the next 1 to 2 months, depending on how we finalize everything. I know our team wants everything to be as perfect as possible before we release it to the whole world. And so if you're interested in learning more and staying up to date about these deliverables, there's a few ways to do this. One, join the Alliance for Water Efficiency. As I mentioned, we're a nonprofit that extends across North America. And if you're not a member, we'd always love to have a new utility or stakeholder to introduce everyone to our network, and you can benefit from these resources, obviously. Number two, if you are a member, check our website, emails, and social media. We'll be constantly updating everyone on the progress of the CTEM and the rest of the cooling technology resources. And finally, you can directly email me if you have any questions. My email is brad@allianceforwaterefficiency.org. You could also email Maureen Urbesnik. She is the head of Urbesnik and Associates, who was one of the main, or is the lead author on a lot of the cooling technology studies. So thank you very much, everyone.